Good morning, children. In today's session, I am going to take science for the 6th standard. That is lesson 3. So already we finished 3 lessons for you. And this is unit 3, matter around us. So in this lesson, first we'll see the introduction, children. Matter is everywhere around us. Okay, matter is everywhere. Everywhere around us. And the air, where we can find the air we breathe, that is a water we drink, the material we use, those, all these are made up of matter. So matter is defined like saying that it occupies space and has mass. So matter is defined as anything that occupies space and has weight. So what is matter, children? When anything that occupies mass and has weight. So space is nothing, that is a add-on already, that is mass is nothing but the weight. Then matter is found in 3 major states, that is solid, liquid and gas. Solid, liquid and gas. So solid, liquid and gas, these are the 3 major states. Another one question is asked here, children. Do you know what is matter made of? What is the question? What is matter made up of? So matter is made of atoms. So matter is made of atoms. So you'll be asking what is atom, right? So atom is nothing. It's the smallest particle of a matter. So atom is the smallest particle of a matter. So what is that atom, children? The smallest particle of a matter. Now they are so small that you cannot see even with your eyes or even with a microscope. So you cannot see with your eyes nor from the microscope because they are very small. Then science has come up with a technology to identify the structure of atoms. So the science has introduced a technology to find the structure of atoms by using ARM. So what is ARM? Atomic Resolution Microscope. And TEM is Tunneling Electron Microscope. So they are going to see the structure, identify the structure of atoms by using this. So that is Atomic Resolution Microscope and Tunneling Electron Microscope. So with these 2 microscopes, they are going to identify the structure of atoms. Now, physical nature of matter. Now, already I said that matter occupies space and has mass. So what is the definition I said for matter? Matter occupies space and has mass. Now, what is its nature, they have asked. That is, matter is made of some smallest particles called as the atoms. So what I told, it's made up of smallest particles called the atoms, and these atoms are extremely small, even to see under a powerful microscope. Even in the powerful microscope also, these atoms will look very extremely small. So this is the atom, children. See here, this is a atom. So inside you have a this is the nucleus. These are the neutron and this is a proton and electron. Okay. So this is the atom. So in the atom you can find nucleus, neutron, protons and electrons. Now we will see the molecules separately, that is. So these are the atoms. Okay. Atoms. And in this, if you take a matter, for example any matter, in this you will see. So these are the molecules. Okay. These are the molecules. Okay, children. Now we'll see the characteristics of the particles of matter. Now particles of matter have a lot of space in between them. Space means what I said, the place. Okay, that is add-on children. Yeah, lot of space in between them. In different forms of matter, the space will be different. So in different matters, the space also will be different. It will not be same. So for example, if you see, let us add a spoonful of sugar to a glass of water. Okay, this is glass of water. You are putting a spoon of sugar. Okay, you are putting the sugar inside the water. Okay, now stir it well. Stir means what? Nalla kalakno. Okay, yeah. Sugar disappears completely. That is, when you add a sugar and stir it with the water, what happens? The sugar disappears. Okay, disappears completely. Then where has it gone? So sugar disappears. Then where it has gone? That is, will the glass of water be now sweet? The question is asked. So for the first one is, water particles have space between them, and the sugar particles are occupying those spaces. So spaces are there. So what happens when the sugar is added? This sugar occupies the space between them. And the particles of matter attract each other. It is a force of attraction which keeps the particles together. Now this attractive force will be different for different forms of matter. So this force of attraction will not be same for all the forms of matter. So it will differ. Now matter can be grouped into solid, liquid and gas. I already told you that is formed as a grouped into solid, liquid and gas. Now there are three physical states of matter, that is solid, liquid and gas. I already told you all. Now mass, shape and volume of solid, liquid and gases we are going to see. Now first question is, let us first take any solid. For example, a stone. Okay, stone is a solid. Now the questions are asked, we have to answer it. Do you need a container to know the shape of a stone? You have to say yes or no. Then another question is, if you move the stone from the ground to a table or place it on the shelf, does its shape change? You have to say yes or no. That is, a solid, for the first one, a solid does not need a container. For the solid, no need to have a container. It stays as it is because its particles are tightly packed. That is, in the solid, the particles are tightly packed. So there is no need of a container. Okay, they are tightly packed. Then, and has a definite shape. So if you keep a stone in the table or in the any other place, the shape of the stone is not going to change for you. So it will be as the same as it is. Then if you take the stone from the ground, place it on the table or shelf, its shape and volume do not change, as I already said for you. Then, so what will be the answer, children? Do you need a container to know the shape of a stone means? No. Then if you move the stone from the ground to a table or place it on the shelf, does its shape change? No. Okay, so the answers are no, because the solids are here, the particles are tightly packed. Okay, so there is no change in the shape and the volume. Then they have given some examples, students. That is, for example, pencil and books are used for studying. Bucket and the comb are made of plastic, while the table and ladle are made of wood. The scrub brush and the broom are rough, but the toy bear is soft. Light can pass through the glass of water and the spectacles, but not through the apple or iron box. That is, first they have given the example, pencil and book. So what we are using that for? Studying. Next, the bucket and the comb. How they are made of what they are made? They are made up of plastic. And the table and the ladder, these are made up of wood. Then the scrub brush, we are using the scrub brush now. That is, and the broom, is rough. But the toy bear, that is, you have to play, that is toy bear. How it feels if we touch means it is soft. So as saying that light can pass through the glass of the water as well. I already said that, transparent. And the spectacles, that is the specs we use, but not through the apple or the iron box. So apple is a opaque material, so the light will not pass. then the cow and the bird are the living things while the rest are not. Water in the glass is a liquid. So water is, already I said, water is a liquid. Yeah. Then air in the balloon is a gas. So air in the balloon is a gas. So air can spread everywhere. Yeah. Then and the rest are solids. So first we have seen the liquid, that is a water in a glass is a liquid. And the air in the balloon is a gas, and the rest is, that is other things, is the solids. The feather, the feather and the paper cup can float, okay, but not the apple or a piece of stone. So the apple or a piece of stone will not float, but the feather and the paper cup can float. The rubber band can be stretched. So everyone knows rubber band, how we put also, we can stretch the rubber band, but not the comb. So we cannot stretch the comb. So though they have different properties, but they are the matter only. Okay, they are the matter, but they have different properties. Then we'll see for examples, we'll see that brick and door, they are hard. Kadinamanadhan solraliya, they are hard and comes under solids. So the examples for solid is brick and door. So what are the examples of solid? For example, given brick and door. And things that flow comes under liquid. So things that flow, okay, comes under liquids. Then for example, water, river, these are all flowing. Yeah, so these comes under liquids. And the others which are very light can flow more freely comes under gases. That is, can flow more freely. That is air in the balloon. So these can flow more freely. So these comes under gases. So what are the examples? Solid, brick and door, liquid which can flow easily, and the gases which can flow more freely. So for this they have given here. Then next we will see the diffusion. Now let us place a book on the table. Let it not be disturbed. That is, we have to keep a book on the table and we should not disturb it. Okay, so in that it should not be disturbed. Now observe for 5 minutes. So you have to see after 5 minutes. Now take a glass of water and add a drop of ink at the center. That is another experiment is, you have to take a glass of water and what you have to add? A drop of ink in the center. Do not shake or stir. That is, you should not stir it. That is kalakaron, mix it, or you should not shake. So what you have to do? You have to take a glass of water, add a drop of ink. At the center you have to pour it. And do not shake or mix it. That is, stir it. And the next one is, now light an incense stick. Udubati solraniya, incense stick, and keep it in one corner of the room. So what you have to do? You have to light an incense stick and you have to keep it in the one corner of the room. Now we will see the answer of the question. So 3 questions I asked. That is, first you have to place a book on the table without disturbing. And the second question is, you have to take a glass of water and add a drop of ink and you should not shake or stir it. And the third one is, you have to light an incense stick and keep it on the corner of your room. Now, did the book move is the questions. Did the ink particles move and spread itself in the water? How long did it take for complete mixing, that is stirring? Did you get the smell of the incense stick from where you are standing? How fast did you get the smell? How did the smell reach you? So these are the questions asked. So that we will conclude that the particles of gases and the liquids can move easily and quickly. So I said liquid and gases, they can flow. Already I said flow, and the gases can flow more freely. So the gases and liquids can move easily as well as quickly, and this particles spread out in order to occupy the available space is called as a diffusion. That is the space ediko and that full spread agum. Okay, so it has a tendency to spread out in order to occupy na and the available space is called diffusion. So what is diffusion, children? The tendency of particles which spread out to occupy the available space is called as a diffusion. Now solids are tightly packed, so they do not diffuse like liquid or gases, that is they do not spread like liquid or gases. So because the solids are tightly packed. Now so the ink so hence ink and the smoke spread easily while books stay tight on the table. So why the book says staying tight on the table? Because the particles are tightly packed. But in the liquids and gases, they can move easily and quickly. So that is the this one. Now what is diffusion? I said that is a tendency of the particles which spread out in order to occupy the space. That is called as a diffusion. So what is diffusion? Tendency of particles to spread in order to occupy this available space. So whatever space is there, it occupies. Okay, that is called as a diffusion. Is diffusion. Did you understand what is diffusion, children? That is, a particles spread in order to occupy the space. Okay, whatever space is that occupies the space. For example, if we take a room, that it occupies the room fully. Okay, that is called as a diffusion. The smoke, that is incense sticks, spreads everywhere. Yeah, that is called as a diffusion. Now they have given here tabular column, that is particles in a solid, particles in a liquid and particles in a gas. Now first, if we take solid, I said already that they are tightly packed. In solid, the particles are tightly packed with very little space between them. Because see, there is no place. Very little we can see. Okay, so there is no space, little space in between them. That is what I said, the particles are tightly packed with very little space between them. So, solid, they are tightly packed and they have little space, that is place, okay, little space between them, that is I showed like this, okay. So we can see the little space which you can found there. So next is a liquid. So what happens in liquid here? Here they are, particles in the liquids are arranged in a irregular way or in the random way. That is, see the picture here, that is here, here, here. That is irregular. Enga venano irkalam. Okay, yeah? Like this. That is in the irregular way. In the irregular way or loosely packed. Okay, or loosely packed we can say. And this is, and the space, already we saw here that the space is a little here. But in the liquids, the space between the particle is greater than in the solid. That is, space is greater than in the solid. Because in solid we have little space, right? So we have little space there. But here in the liquid it's greater than the solids. Adavida konjam jastiya irukum. Next is particles in a gas. Here in the gas what happens? The particles are arranged far. Okay, the particles are arranged far and they move freely. What happens? They are very loosely packed. In the gas, they are very loosely packed and they move freely. Okay, so the gas are arranged far and they move freely. They move freely. That is, romba dura durama irukkum particles alla. Okay, so the particles are very far apart and they can move freely because they are very distant. So they can move freely. Then for the first one, solid, you can take stone. Okay, that is very hard. Okay, that cannot move freely. Next is a water. That is a liquid. Nia. Water is a liquid. So there is a loosely packed here. The particles are loosely packed and the space here is greater than as a solid. Now if you take gas example, air. So air is very, here the particles are very loosely packed and they can move freely. So this is the tabular column given here, children. It's a property particles in a solid, liquid and gases. So what we saw solid, they are tightly packed and they have little space. So this is here. For example, is a stone given here. Then in the liquid, that is an irregular way, or they are loosely packed, and the space is little more greater than the solid. Then in the gases, they are very loosely packed and they can move very freely, and the example is given here is air. So in the next class, we'll continue, children. That is, we'll continue with the compressibility of gases compared to liquids and solids. Okay, children? So, thank you.